If you want to draw a cat, and you're constantly comparing what you draw with your cat, this process is similar to how a neural network learns. If you see how you draw a cat as a function, neural networks approximate its function. Okay, but how does the computation work? Let's start with a simple example, the feed-forward neural network. Neural network can be reduced to any type of regression. Let's use logistic regression on this problem. A very simple neural network with only one input neuron, one hidden neuron, and one output neuron is equal to a logistics regression model. Now you want to predict a cat's gender according to its weight, whether it sprays, and how aggressive it is. In case you didn't know, female typically weigh between 8 and 12 pounds, while male typically weigh between 11 and 15 pounds. Male cats spray more often than females, and also they are more likely to be aggressive than female cats. Now you collected a bunch of data from cats. You want to know if Alex is a male or a female. You'll have weight, spray, aggressiveness as input variables. For each variable, you multiply it with multiple weights. Weight multiplication at each layer is a linear transformation. Now this model can just get as powerful as a linear regression. We want the model to learn more complex functions than linear regression, so we wrap the improved function with a sigmoid activation function to break the linearity. Sigmoid function exists between 0 and 1. It is especially used for models where we have to predict the probability as an output. Now this information goes to the nodes in the hidden layer and then to the next hidden layer. We can increase the complexity of the model by using multiple neurons in the hidden layer. You can have as many hidden layers as you want. The final layers will produce values like this, which are not normalized and cannot be interpreted as probabilities. We can add a softmax layer to the neural network to translate the numbers into a probability distribution. Oh wait, your prediction is still pretty far away from the labels. Because your weights and biases are not right, the prediction error of the neural network is called loss, and the method to calculate the loss is called loss function. There are many types of loss functions. For each prediction that we make, our loss function will simply measure the absolute difference between our prediction and the actual value. If your prediction is totally off, your loss function will give a higher number. Then we will adjust the weights and biases a bit and do another iteration. For every iteration, it will perform gradient descent to find weights that are better and fit the data, until the prediction results do not change drastically anymore. This is the training process of neural network. However, neural networks are prone to overfitting. In order to have a less biased model, you need to collect data from different breeds of cats. You need lots of cats.